And in addition to GIS, there are other relatives of GIS, other what we call geospatial technologies. Some of these are visualization technologies, such as Google Earth. And it also extends to what's called remote sensing. And this is about data collected from far away, primarily by satellites, but it can be it could be a drone or an airplane, for example, as well. And that remotely sensed data can be integrated into a GIS. So for example, we talked about different kinds of maps, and we looked at thematic maps, including isoline maps, including contour maps. And a contour map is using lines of equal elevation to display elevation information on a flat two-dimensional environment. However, with more modern technologies, we can create what's called a DEM, or digital elevation model, which is a sort of a type of GIS file that includes information on elevation that allows us to visualize the three-dimensional environment rather than have to interpret it in a two-dimensional space. And the way it works is that it is a raster file. The raster are the grids of information. It's kind of like a digital photo. A digital photo would have these pixels, and in a digital photo, it would also, each pixel would store a number, and that number would tell you the color that little pixel is. Technically, it stores like 3 layers, one for red, one for blue, one for green, but it's the same idea. Now, in this digital elevation model, it also stores numbers, but rather than those representing colors, they represent heights or elevation. So here, each cell has a number which tells you how high that cell is in elevation. And what a computer can do is render that in three-dimensional space. So if you've ever looked at Google Earth, Google Maps, where it shows things in 3D, you'll see that it's using in the background these. You can actually, this is how they display these things in 3D, is that underneath they have these digital elevation models. So DEM is a digital elevation model. All right, and a big other technology, especially in physical geography for monitoring the Earth, is remote sensing. This is about collecting information from a distance. Satellites, airplanes, drones are becoming a big source of remote sensing. And one thing that we'll kind of key in on is that these are not just taking pictures, but these are digital measuring devices. And the information to collect is beyond what our eyes can visualize. So it's beyond visible light. For example, it collects something called infrared. This is something that is beyond what our eyes can see, but satellites can utilize this to help measure and measure the amount of vegetation in a given area. All right, so when I say beyond what our eyes can see, this has to do with the electromagnetic spectrum. And the electromagnetic spectrum is something that goes from shortwave radiation, like X-rays and UV light, stuff that can, give you sunburn, to long wave, so Wi-Fi, radio, or long wave. And so all of these things are on the spectrum of electromagnetic radiation. Now, this is really condensed to fit onto a slide, but it's a long range of different kinds of things. Now, there is a small part of this that's called visible light. And this is the type of light that our eyes are attuned to sense information. In other words, this is the part of the light that our eyes can detect and see. And it goes from blues up to reds. So the really dark blues are kind of look violet, and that's why below there it's called ultraviolet. It's kind of below the violet. And then it goes to the reds, and beyond there it's called the infrared. It means kind of beyond the red. And so infrared is the one we mentioned, where satellites can use that to detect vegetation, because we can't see this ourselves, but vegetation is very bright in the infrared. We just don't normally see that. And So one type of remote sensing is called multispectral remote sensing. And so what that does is detects many bands of the electromagnetic spectrum at once. This usually includes parts of the stuff our eyes can see, the visible range, like the colors like blue and green and red, but also stuff that our eyes can't detect, like infrared, for example. So let's blow that graphic up a little bit. So for this particular satellite, it's called Landsat. It's collecting sort of slices of information. The first band is sort of in the range that we would see as blue. That's in that kind of part of the spectrum that would be blue information. Part of it would be detecting how green things are. Part of it would be detecting how red things are. And by the way, as one thing I mentioned earlier is a digital photo does this as well, but it stops with these three. It collects the blue, the green, and the red, and it can combine those to make a true color photograph. Each one of these are like a raster where it has numbers that represent how blue it is on one, how green it is on one, and how red it is on the other, and it can combine those to make a color photo. Now, with these satellites, though, they don't have to stop there. They can collect beyond our visible stuff. They can, one called the near infrared, one called the middle infrared, something called another part of the middle infrared, and this one here is called thermal infrared. So the reason why it's kind of sandwiched there is that they added this seventh one on later on. But anyway, the thermal infrared is really detecting more heat, so which is another part of the spectrum as well. Here's another way of looking at it. So the wavelength, so blues are in these kind of range of wavelength. It has a one layer of blues, one layer of greens, one layer of reds. And take these together, this would normally be what a digital photo is like, but it goes beyond that. It collects near infrared, middle infrared, shortwave infrared, and thermal infrared. And because it's collecting more stuff than your typical digital photograph, it allows you to remix these colors. And so what you can do is you can say, display, while your eyes can't see near infrared, you can kind of remix your digital photo to display it as red. So for example, in this picture here, all the stuff that's very red here is really bright in the infrared. And you wouldn't normally see that in real life, but you can make what's called a false color image to help you visualize that. So for example, this is out in a desert, and where things have very bright vegetation, they're going to be very bright in the red because you're kind of remixing these colors. And so here, bright red means that there's vegetation, like a golf course. Most of these are golf courses or people's yards. So this red stuff is living vegetation. And the reason why it doesn't look green is because we've remixed these colors to enhance the visualization of it. And now, multispectral remote sensing is really just kind of absorbing information that's already there. It's detecting reflected sunlight or emitted heat. There's a second type, and we call that passive remote sensing. But there's a second type called active remote sensing. This is where the satellites are actually sending out a signal and measuring their return. And there's three general types of active remote sensing. One is radar, and radar, kind of like, you've probably heard of radar for different applications, but I'll give you an example. This top image here is taken by something called the Shuttle Radar Topography Mission. This was done back in the 1990s when we had space shuttles, and the space shuttle took this massive piece of radar equipment and flew around the Earth and took radar images that developed to create digital elevation models for most of the Earth. And I'll come back to radar in a moment. Now, sonar is something like that, but it works underwater using sound waves. And sonar is underwater stuff. And LiDAR is kind of like radar, but it uses laser light. So it makes very precise laser measurements to get very detailed terrain measurements. Makes very detailed digital elevation models. Now going back to radar, now the shuttle flew this mission in a fixed amount of days. And this is Ireland. This is the island of Ireland. If you know anything about Ireland, is that Ireland is typically cloud covered, very wet and cloudy. However, that's not a problem here, because one advantage of radar is that radar moves right through clouds. It is not obscured by clouds at all. A second thing is that active remote sensing like radar isn't dependent on the sun. So the shuttle was capturing images day or night because it wasn't looking at reflected sunlight. It was simply measuring the return of the radar signals that were sent out by the shuttle itself. So if we work at night, all kinds of weather. And so there are some advantages to things like radar and other forms of active remote sensing.